Good morning and welcome to the Intellectual Property Management Seminar Series. Before we start, please let me explain how we will manage this meeting. BlueJeans works best in the Chrome browser, so if you've connected using another browser, you may wish to exit and reconnect with Chrome. You should also disconnect your VPN. Today's session is a mix of live and pre-recorded talks. Due to the makeup of the event, there won't be a live Q&A, but attendees are invited to post questions in the event chat or email questions to partners@anl.gov. S&TPO and/or legal will then respond in a timely manner with answers. Today's session is being recorded and may be available for viewing after the meeting. By participating in today's session, participants consent to being recorded. And now I'm happy to introduce Glenn Mcewen, General Counsel of Argonne National Laboratory.
Good morning, and welcome to Day 2 of the 2021 Intellectual Property Management Seminar Series. Argonne Science and Technology Partnerships and Outreach Directorate, also known as S&TPO, and the Argonne Legal Department are once again hosting this annual series, and we are excited for today's sessions titled Growth Through Inventing: How Patents Improve Research Collaborations and Careers. I want to offer my sincere thanks to all of you online for taking the time out of your busy schedules to attend today's program. We have a terrific group of speakers who will each present a brief talk, but before we hear from them and go further in depth on the subject of patents, I would like to provide some background and context. Argonne's management and operating contract with the Department of Energy defines the mission and goals of the laboratory. In Clause I-113 of the contract, technology transfer is identified as a mission of the lab. To fulfill its technology transfer mission, Argonne is charged with the stewardship of the intellectual property, or IP, that is developed at the laboratory. The lab is also responsible for establishing internal capabilities and utilizing mechanisms authorized by DOE to identify and push the IP out to partners in academia, industry, and government for further development and use. So what is intellectual property? Intellectual property are assets that are derived from human intellect, such as inventions, discoveries, and expressions of ideas that are protectable under law. There are three principal types of intellectual property that are managed at Argonne: patents, copyrights, and trademarks. The presentations during today's seminar will focus on patents. I'm going to provide a very basic description of what a patent is. Much more detailed explanations of patents and their value will be provided to you today by individuals with far more expertise and experience in this area than I. A patent is a grant by the government of an exclusive property right to an invention for a specific period of time. The owner of the patent has a right to exclude others from using, making, or selling the invention for the life of the patent. Now, the capabilities that exist within S&TPO and the legal department are here to assist the laboratory and its researchers in fulfilling this technology transfer mission. In the legal department, we have 3 attorneys and 2 paralegals whose work is largely devoted to this mission. The members of the IP team have over 90 years of combined intellectual property and tech transfer experience, with about 55 years of that experience right here at Argonne. 2 of the members of the legal department's intellectual property team, Mark Hilliard and LaShondra Moore, will be presenters during today's program. Before I turn it over to our next speaker, I just want to say that I hope you come away from today's session with a greater understanding of patents, as well as Argonne's processes for protecting and developing intellectual property. A prior commitment will preclude me from hosting the rest of today's session, but you will be in good hands with Pete Sloniak, Senior Attorney for Intellectual Property at Argonne. Our next speaker is Karen Bluin. Karen is an Assistant Chief Counsel of Intellectual Property Law for the Department of Energy. In this role, Karen provides legal counsel on matters relating to intellectual property and technology transfer for several national laboratories, including Argonne. Before coming to DOE, Karen practiced intellectual property litigation as well as patent preparation and prosecution at various law firms in the Chicago area. Karen began her career as an astronautical engineer in the U.S. Air Force, designing and developing guidance and control systems for ICBMs. Karen couldn't be with us live today, but she has pre-recorded remarks on DOE patenting of Argon inventions, prior art searches, and related topics. So please take it away, Karen.
Thank you, Glenn. Good morning, everyone. Thank you for giving me the opportunity to present at Argonne's IP Management Seminar Series. I am Karen Bluin, Assistant Chief Counsel for Intellectual Property for the Department of Energy. In my role as Assistant Chief Counsel, I oversee the invention management for several national laboratories, including Argonne. Some of you may be surprised to learn that the DOE files patent applications on Argonne subject inventions. In fact, the DOE files patent applications on approximately 5 to 8 Argonne inventions per year. The DOE decision-making process that determines which invention disclosures will be chosen for patent applications does not always align with Argonne's motivations. In some cases, it does. For example, the DOE may file patent applications that will potentially result in licensing opportunities down the road. In other instances, DOE may file patent applications to seek a return on taxpayer investment. For example, if there has been significant government or taxpayer funding in a specific field, filing a patent application discloses the scientific gains to others. Filing a patent application may aid in the growth of the technology when outside parties take the information from the patent application or patent and move the work forward. DOE may file patent applications to ensure U.S. businesses aren't shut out of a technology field. This is referred to as defensive patenting and is a tool used when there is work in the same or similar field outside of the United States. Defensive patenting may also be appropriate if the technology is in an area in which the U.S. government has particular interest. Finally, DOE may file patent applications to ensure there is attribution in that field to both DOE and the inventors. The Argonne Prime Contract outlines the treatment of subject inventions. Subject inventions must be disclosed to DOE Patent Counsel within 2 months. Argonne then has 2 years to elect to retain title unless there is a statutory period ending sooner. If there is a statutory period ending sooner, Argonne has 60 days prior to the end of the statutory period to elect or decline to elect title. The statutory periods most common in the lab environment are periods that relate to publications such as papers and posters. DOE takes title to all lab inventions for which Argonne elects not to retain title or for which the lab failed to disclose or elect within the time periods outlined in the prime contract. It's important to note that DOE may not have title to a lab invention for 2 years after the subject invention was disclosed. When DOE Patent Counsel receives notification that the lab declined to elect title, the first thing Counsel does is to review the disclosure. Then comes the hard part. We need to catch up on the past 2 years. DOE Patent Counsel will contact one or the inventors for updated information. This can include additional publications, if there is a subsequent reduction to practice, any successes or failures of the technology. It's also important to note any follow-on disclosures. If the subject invention has been further refined and updated in a subsequent invention disclosure, please pass that information on to DOE Patent Counsel. The most basic statutory guidance for patentability is that an invention must be novel, non-obvious, and useful. That guidance is fairly gray, and it's difficult or even impossible to say with complete certainty whether or not a patent application will result in an issued patent. However, it is easy to determine which inventions will not be patentable due to certain circumstances. First, there's a 1-year grace period on public use, offers for sale, and publications for U.S. filings. This means that as an inventor, your patent will not be barred if you file a patent application within 1 year of publication. While filing after publication is allowed in the United States, it's not recommended practice because the U.S. Patent and Trademark Office operates on a first-to-file basis. Your date of conception, like the date signed on your invention disclosure, does not hold your place in line. You may want to be the first to file a patent application in your technology. A third party's action may also invalidate your patent, which we will discuss more in the next slide. If a third party copies your invention and files a patent application, there's a chance this action could prevent you from filing a patent. Some common bars to patentability common to the laboratory settings are making a disclosure that isn't protected by an NDA or public use. Offers for sale would be less common in a laboratory setting. Publications such as posters, articles, patents, or patent applications can be a bar to patentability. The document can be physical or electronic and only has to be accessible by the public. It doesn't need to be widely disseminated or even easy to find. Prior art by third parties is a meaningful source of information that can be a bar to patentability. Third-party prior art includes publications, advertisements, and products for sale. It also includes patent applications and patents. Importantly, an abandoned patent application can still bar your invention from being granted a patent. Finding third-party art isn't an activity relegated only to the patent attorneys. You can do prior art searches as well. For starters, as a PI, you know who's in your field. You know who's working on similar projects, and you can Google colleagues in your field in either Google or Google Scholar to gather any publications or patent applications. To find related patent applications or issued patents, use Google Patent. In the example here, I used Google Patents with the search term golf ball. It pulled up about 124,000 results. I chose the first result, multi-layer golf ball with a thin thermoset outer layer, to continue my search. U.S. patent number 8,109,843, or the 843 patent. This is a portion of the first page of the 843 patent. The bottom left corner is a listing of the classes in which the examiner determined this invention belonged. The classes and subclasses are a useful way to refine your search. You can use Google Patents or even the USPTO website to bring up other patents in those specific classes and subclasses. The inventions listed should theoretically be somewhat similar to the one you searched. Issued patents also have a list of U.S. patents and patent applications that the examiner determined were similar to the issued patent. You can use this list of patents and patent applications to find similar patents. I'm going to switch gears now and discuss more specifics about working with DOE patent attorneys. The next two slides demonstrate the most recent issued U.S. patents that have Argon inventors. I filed all of these patents, and as you can see, the DOE does not play favorites. DOE Patent Counsel does not have favorite divisions, favorite inventors, or favorite technologies. In fact, DOE Patent Counsel seeks diversity in many spaces, from technologies to named inventors. So you're probably wondering, how do you get DOE to prepare a patent application on your invention? Good question. The first steps are easy. If you're notified that the lab has not chosen to elect your invention and you believe your invention is novel and non-obvious, reach out to the DOE Patent Counsel. DOE Patent Counsel has tons of invention disclosures to review, and by being proactive and conveying your enthusiasm for the invention, you will almost assuredly be moved to the top of the pile for evaluation. If you are contacted by DOE Patent Counsel, respond. Answer questions, provide additional material. Remember, the DOE Patent Counsel may have 2 years of material to catch up on. Anything you can provide to aid in the review is helpful and appreciated. Build a relationship with DOE Patent Counsel and remain engaged throughout the process. Build a relationship with DOE Patent Counsel so that you can reach out with invention disclosures down the road. If the opportunity to work with DOE Patent Counsel isn't enough motivation, there are additional benefits to having a patent application prepared by DOE. If the patent application is prepared but doesn't issue as a patent, that patent application is a publication. So at worst, you have an additional publication. If it does issue, you have an issued patent. Patent applications filed by DOE are eligible for the same monetary awards for filing and issuance that you receive for patent applications filed by the lab. You also receive recognition at the annual Argonne Innovators and Inventors event. Finally, you're able to share in royalties if a patent does issue and is licensed. My contact information is listed here. Please feel free to reach out with questions or invention disclosure you'd like to bring to DOE's attention. Thank you.
Thank you, Karen, for sharing the important role DOE plays in protecting laboratory inventions. As Glenn mentioned, I'm Pete Sloniak, a senior attorney for intellectual property at Argonne National Laboratory. I will be acting as your host for the rest of the way today. Our next speaker is Alina Kastman, an X-ray optics fabrication specialist in Argonne's X-ray Sciences Division. Alina has twice successfully completed DOE's impressive Energy I-Core program, once as a principal investigator and a second time as an entrepreneurial lead. Via recorded remarks, she will share her experiences with Energy I-Core and how intellectual property laid the foundation for those opportunities. Turn it over to Alina.
Hello, my name is Alina Kastman. I'm an X-ray optics fabrication engineer with the X-ray Science Division at the Advanced Photon Source. And I'm glad to be here with you today virtually to share my Argon journey with intellectual property, commercialization training with DOE's Energy I-Core program, and the impact that those experiences had on my work and ultimately on my career progression. Energy I-Core is a key initiative of the Office of Technology Transitions. During the program, national lab researchers are teamed with industry mentors to investigate potential market pathways for their innovations. The teams learn and practice to define technology value propositions, conduct customer discovery interviews, and eventually develop viable market pathways for their technologies. The research then returned to the lab with a framework for industry engagement to guide future research and inform a culture of market awareness within the labs. Energy I-Core program this way is ensuring that our investment in the national labs is maintaining and strengthening U.S. competitiveness long term. The APS, the Advanced Photon Source, is a powerful source of X-rays that are used to study the structure and properties of materials. We use a variety of optical components for each experimental setup to fine-tune the generic X-ray that the APS outputs and make it suitable for that particular purpose. One of such optical components is the channel-cut crystal monochromator. Its two diffracting surfaces select a dedicated wavelength out of the APS X-ray beam while maintaining the same direction of the beam with a small offset. In order to deliver the best optical properties of the beam to the sample, we have to polish these two surfaces that are partially concealed. So how do we do that? The simple solution was to take a small handheld tool and polish the inner surfaces with some elbow grease manually. This worked, but it was not a sustainable solution. The results were not easy to replicate, scale, or even achieve safely due to the risk of repetitive motion injuries. So, after much trial and error, we thought up a concept of automating the process and built the first prototype. This sketch, made in my lab notebook during one of our brainstorming sessions, later became our prior art in the patent application. This highlights the importance of documenting your ideas and dating your notes, just in case they lead to successful outcomes. Our first prototype, pictured here, had all the necessary components. It had wood, unistrut, plastic tub, and a little bit of double-sided sticky tape. But most importantly, this first prototype produced excellent results. And this is what they call in the intellectual property world reduction to practice. Now that we had the working prototype, we submitted the Invention Disclosure and planned a technical talk and paper at the SPAE conference. Myself, having gone through the Energy I-Core with someone else's project previously, I knew the value of the program and applied as soon as we had a good team formulated. The whole experience really informed us to design and build the actual machine to have the look and feel of an industrial equipment. It is convenient to use and serves as a good introduction for prospective licensing partners. Additionally, through customer discovery, we identified needs for future development and submitted subsequent invention disclosure that has not yet been reduced to practice. Overall, The relatively short Energy I-Corps program had a big impact on the way I approach projects at work. A mindset shift, if you will. I ask better questions. What problem are we trying to solve? Which informs then our design solutions. And these new solutions that I develop end up more elegant and easier to implement, reducing costs and improving workflow, as well as encouraging cooperation with others. In summary, I am a big fan of the Energy I-Corps program and encourage everyone to participate. If you don't have your own invention, find someone else and join their team as their entrepreneurial lead. That's what I did before I had my own patented invention when I participated with Cohort 1 of Energy I-Corps. Feel free to reach out to me if you have any questions on the Energy I-Corps program or would like to know more personal stories about going through it.
Thank you, Alina. We appreciate you sharing your experience with IP in Energy I-Corps, an important program to the DOE and Argonne. Next, we will hear from Mcewen, a principal materials scientist in Argonne's Applied Materials Division. Mcewen works on complex battery and polymer technologies. As you will hear, Mcewen has a robust and growing patent portfolio. Via recorded remarks, Mcewen will share her experience growing her program and relationships using patents. I turn it over to Mcewen.
Good morning. My name is Yuepeng. I'm a materials scientist at the Applied Materials Division. Today, I'll be sharing with you my experience with patent applications and how patenting has helped me grow my research program. As we all know, invention is the most important product of scientific knowledge. When we develop a new finding or new technology, we naturally think about publications. This is what we have often been trained within our education. Many times, we forget that we could have or we should have filed a patent before we publish our results. Why is this? This is because patents and copyrights provide Argonne with intellectual property and the main vehicle with which to grant companies and manufacturers the right to use our technology in their production, as well as to build new technologies on top of our original inventions. This will lead to continuous technology improvement and a collaboration between Argonne and industry. It also provides us, the researchers, the opportunity to grow our research program. Moreover, according to Argonne's prime contract with DOE, Argonne has the responsibility to report all inventions. Now, I would like to give you my own example of how I grew my program through patenting. When I joined Argonne a few years ago, my research group had a CRADA with a company to develop new materials for radio frequency devices based on an existing patent. With this CRADA, the group was able to test and validate the idea, which resulted in 2 joint DARPA projects. For each project, we then had a new collaborator join the team. During these projects, we were able to improve our materials and move the technology to a higher maturity level. We first demonstrated materials with the desired properties and then integration of these materials into the wafer process. Finally, we successfully built a prototype device that showed operation within the expected frequency range. In this overall development, we generated multiple invention reports and patents, which attracted a 4th collaborator. Because of this strong collaboration effort, the whole team moved into a new phase of the project. Also because of our patents, our collaborators have a continuous motivation to mature the technology with us, as well as a strong incentive to implement Argonne's technology to their products. We built a strong relationship with multiple collaborators. Our main partner company even wanted to expand the collaboration to other technologies and application fields. Thus, we jointly applied for a technology in residence project, which provided us the opportunity to explore other collaboration topics. In order to differentiate the IPs generated by each party within such an interconnected effort, Argonne's legal prepared an IP management plan that allowed mutual protection of the interests and benefits of all parties. Since we have more than just one collaboration, each project had its own IP management plan. We're now in the third phase of the DARPA project, and the entire team is looking forward to the next level of development. As you can see, patenting really accelerated our R&D through collaboration with other institutes. I strongly recommend that you report your inventions. In terms of how you know that you have an invention, different people will have different answers. But as a rule of thumb, you can check the following list. First, whether your ideas or technologies show novelty and advantages over the existing technology. Second, whether your new technology has a commercial value. Can it be used for real-world applications? Actually, this is the most practical question that you should think about before you even develop a technology. If these tips are still not enough for you to make a decision, you can always file an invention disclosure before you publish your results. Similarly, you should consider reporting your invention before you discuss your research with external collaborators. Do not worry that your idea is still conceptual. You have the choice to file invention disclosure or even a provisional patent. A provisional patent establishes an early filing date but does not mature into an issued patent unless the applicant files a regular non-provisional patent application within a year. This means that you have 1 year to reduce the concept to practice and convert the provisional application to a non-provisional one. Finally, don't hesitate to reach out to our legal and STPO teams. They always have our back and would provide the strongest possible support and protection. Thank you for your attention. Please feel free to contact me if you have any questions or would like to discuss this more offline.
Thank you, Yupeng, for sharing how your inventions have led to additional collaborations. Our next speaker today, Austin Clyde, is with us live. Austin is a PhD student at the University of Chicago's Department of Computer Science. He is also a computational scientist in Argonne's Data Science and Learning Division. Austin is an inventor. He recently reported an invention involving the application of artificial intelligence. Today, he will share his impressions on his first time through Argonne's invention review process, known as the IP Decision Group Meeting. Take it away, Austin.
Hi, everyone. My name's Austin, and I'm in the Data Science and Learning Division. Recently, Rick Stevens, Arvind Ramanathan, and I reported an AI-based invention to the Intellectual Property Decision Group. Our invention is a method for optimizing pharmaceutical drugs. In many ways, it's just a methodological improvement to the drug discovery process, but it's based completely on computation. You may be surprised that this non-tangible AI method is in fact patentable. Today, I want to talk about our experience from recognizing we had an invention to the process and where we are today. So recognizing your research may be an invention versus incremental process is a hard problem. Often, the research we write represents incremental progress. In the AI space, there are two branches of work. One of them is about applications where you apply things to data sets and new problems. A priori, not all advances in modeling seem like inventions, but after working with the Ipdg group, looking through AI patents, you actually notice that these are in fact inventions that do solve material problems when you actually implement the methods and run computers in the world. And second part of starting the process was, in the AI community at least, there's a strong ethos for open science. And you may fear going through a patent process might entail a lot of red tape, but we've never had such experience at all. Never have we felt like we've had to limit any communications as a scientist, and in fact, everything's been completely open and on schedule with the normal publishing process. So when do you think you've invented something new? And for me, I found out through just talking with some colleagues, and they were like, oh, wow, this seems like maybe a startup idea. And at that point, it's clear that there must be monetary value, and therefore it must be an invention. From there, we spoke to some colleagues in our department and eventually got connected to the Ipdg group. From there, we just had to fill out an Invention Disclosure form, which essentially was just the background information of the invention and the typical things one includes in an introduction of a research article. The meeting itself was not much different than a typical seminar presentation where you just come prepared with a few more details instead using Google Patent instead of Google Scholar. And in general, for AI and patents, I was shocked at how many AI patents are out there. And again, you'll find a startup for almost every single patent. I was surprised to see many AI papers that actually ended up resulting in patents when at the time you just think it's a paper at a conference. From what I've gathered, AI methods are patentable, and the trick is to ask, based on all other patents out there, is what I've implemented unique? In conclusion, don't shy away from the IP process because your work is theoretical or solely computational. As others have discussed, the IP process is about protecting our work and sharing it, and computational work seems no different. Thanks for your time, and feel free to reach out with any questions.
Thank you, Austin, for sharing your experience. We do appreciate it. We are pleased today to be joined next by Ajay Johimiak, Argonne's Distinguished Fellow in the X-ray Science Division. Ajay was one of the first researchers at Argonne to report an invention pertaining to the treatment of COVID-19. Today, he will share his perspective on the importance of IP to the DOE mission in that space. I turn it over to Ajay.
Thank you very much, and thank you for having me. I am heading Structural Biology Center, and also I'm a co-director of Center for Structural Genomics of Infectious Disease. And I want to bring to your attention, how the intellectual property pertain into the pandemics, COVID-19 pandemics. Next slide, please. So in January the last year, the severe acute respiratory syndrome coronavirus 2, which is a therapeutic agent responsible for coronavirus disease or COVID-19 as it was discovered. And then the first patient was actually in the United States, was discovered in February. And this little nasty agent is actually so far caused more than 138 million infections worldwide, and of almost 3 million deaths. In the United States, it's over 31 million infections and over 500,000 deaths. Now, there are several new variants circulating worldwide. Economic impact is relentless and wide-ranging. So we was tasked to find potential cure or treatments for this agent. And at Argonne National Lab, we have the advanced photon source, and we use that facility to help characterize some of these proteins and potential treatments for the virus. Next slide, please. So, what to do? Protect IP or temporarily waive some of IP rules? And this is on many different levels, on government levels, health systems, individual scientists, pandemic, in IP rules. Now, strong intellectual property protection is a cornerstone of American tradition. And protecting IP rights is essential. And it is a very important vehicle to interact with pharmaceutical companies and move inventions into the practical treatment. So IP protection is also has not prevented us to share our discoveries with research community and broad public. But there are concerns. For example, some thinks that sharing the benefits of science widely to protect people's life and reduce health costs is important by temporarily waiving some IP rules. Some people think that the IP rules would prevent scientists from rapidly disclosing research results and the sharing of insight that may lead to treatment with other work. And then I think it's important to share access to treatment, testing, and vaccination. And we have these issues of rich countries versus poor countries, old people versus young people, economy versus health. So there are obviously issues. And so how we did this in the past year. Next slide, please. So the practical solutions for IP in pandemics times was based on collaboration, data sharing, and at the same time protection of intellectual property. Collaborations become essential part of the COVID-19 research, and an example is provided by Department of Energy program, which is called National Virtual Biotechnology Laboratory, which is a collaboration of 17 national laboratories, which was turned instantly in March last year. And this was extraordinary level of interactions and collaborations. Now, some funding sources require data sharing with community. So, for example, structures of SARS-CoV-2 proteins were deposited to Protein Data Bank and made available to biology community. Materials generated in the process were deposited to NIH, National Institute of Health, BEI material repository, and they were available at a small fee. Preprints of manuscripts posted on public servers like bioRxiv and Research Square were also made available to community. Now, IP protection tools that we used during pandemics was we established material transfer agreements with the collaborators. Some of these are also protected between national labs by prime contract protection. We file invention disclosures, and also patent applications were submitted. Next slide, please. So in the past year, we've been working on many structures of this virus. This virus has nearly 30 different proteins encoded by RNA. As you can see on this particular slide, we determined 49 structures of 15 unique proteins from the virus. Those that are marked with red markers are actually important drug targets. And many of the structures that we determined were in complexes with ligands and potential inhibitors and potential precursors for drugs. We put a lot of effort into repurposing existing drugs. Entire community was searching for drugs that potentially, known drugs that potentially can inhibit viral proteins. Next slide, please. So one of the first structures that we determined was the structure of non-structured protein, or NSP15, which is endoribonuclease. And we discovered that the drug, anti-cancer drug, tipiracil, actually binds to the active site of that enzyme, and it blocks activity of the enzyme, as well as it inhibits the proliferation of the virus in cells. So we filed a patent application, and though this drug is not a very strong inhibitor of the virus, it is potentially important for designing a better molecules that will more strongly inhibit that essential enzyme in the virus. And we published this in Communication Biology recently, and also provided access to community in bioRxiv. Next slide, please. The other important drug target is called papain-like protease, or PLPRO. And working together with scientists at the University of Chicago, we have determined that many compounds that are shown here can inhibit the enzyme, but also they can inhibit the virus with micromolar concentrations. And the inhibitors that were synthesized by chemists at the University of Chicago, and we determined their structures are protected. And then we also published a paper in Nature Communication and posted it on bioRxiv for other people to access. This is one of the most important drug targets. We continue actually working on a number of other compounds that can block activity of that enzyme. Next slide, please. And the other important drug target is an enzyme called main protease, or MPRO. And the scientists at the University of Chicago screened almost 2,000 FDA-approved drugs, and they discovered that this compound masitinib, which is also used in cancer treatment and is inhibitor of tyrosine kinase, inhibits the enzyme. And then we determine the crystal structure of the complex, and shown that this compound can be potential compound for drug discovery. So these are examples of research that is ongoing and where we are trying to find potential cures. We also work on antibodies that are provided by some researchers at the University of Chicago, and trying to find antibodies that specifically neutralize the new variants that arise recently. So I'd like to thank you for your listening, and the last slide is out there. Thank you.
Thank you, Ajay, for sharing how you used IP as a tool to help facilitate technology transfer of these important COVID-19 discoveries to pharmaceutical and healthcare organizations. We appreciate you sharing your experience as well as some of the research results. We wish you luck in your continued studies on this important topic. Our next speaker is also here with us live today. Greg Halder serves as a business development executive within the S&TPO Directorate. Greg actually started his career at Argonne at the Advanced Photon Source, where he was a scientist from 2010 to 2015. He returned to Argonne in 2017 after spending 2 years in Austin, Texas, completing his MBA at the University of Texas. While there, he applied his science and business experience to consult with multiple customers on this interface of science and business. In his current role, Greg is responsible for managing Argonne's energy storage IP portfolio, as well as providing business support for researchers on matters like industrial partnerships, SPPs, and CRADAs. Greg will be sharing today insights on how Argonne selects inventions for patent protection in the Intellectual Property Decision Group, or Ipdg, process. Over to you, Greg.
Good morning, everyone. Thank you to Pete for the introduction, and also to the organizers for this opportunity to present today, where I will discuss my top tips on how Argonne selects inventions to move forward to the patent application phase of IP protection. Next slide, please. First up, for any attendees that may be new or unfamiliar with Argonne's invention reporting process, after a new invention has been reported and processed by my colleagues in Argonne's legal department, S&TPO then schedules a meeting called an Intellectual Property Decision Group meeting, or Ipdg, which Austin introduced earlier. The Ipdg meeting attendees include the Argonne Inventors, a representative from the Inventors Division Management, such as a group leader or section manager, a representative from Argonne's legal department, specifically Mr. Mark Hilliard, Argonne's Chief Patent Counsel, who we will also hear from later today, and the Cognizant S&TPO Technology Manager, who is responsible for coordinating the meeting and leading the discussion. So, for example, for battery-related inventions, this S&TPO representative would be me. The goal of the Ipdg meeting is for the group, consisting of technologists, managers, and legal and commercialization experts, to jointly reach a consensus on the best course of action for that invention. The format of the meeting involves approximately a 20-minute presentation by the lead inventor, focusing on the technology and supporting research results, followed by 20 to 30 minutes of group discussion on patentability, as well as commercialization pathways and prospects. The meeting concludes with reaching agreement on the decision and establishing follow-up action items. Next slide, please. There are 3 primary outcomes from the Ipdg meeting, as outlined on this slide. If the decision is made to move forward with a patent application, we formally refer to this as an elect and file decision, where we notify DOE of our decision to elect title to the invention and proceed with patent application drafting and filing. Often at the time of the Ipdg meeting, it is decided that more information is needed, which we refer to as a hold decision. Some common examples of hold decisions are listed here. The most common cases are when critical additional data are needed to differentiate the invention from existing technologies or complete reduction to practice. Finally, if it is decided that Argonne will not move forward with the invention, this is referred to as a return to DOE decision, at which time DOE will review the invention and in some cases may decide to file a patent application. as Karen described earlier today. Next slide, please. Before moving on to my tips, I wanted to take this opportunity to share a snapshot of recent Argonne invention data. In this chart, I've characterized all the Ipdg outcomes from 2020 inventions by Argonne R&D Directorate. While you can see that the absolute numbers of reported inventions are higher for the more applied parts of the lab, which is to be expected, the data also shows that Ipdg outcomes are relatively uniform across the directorates and consequently also across Argonne's diverse science and technology focus areas. Specifically, you can see here that both overall and within each directorate, there are approximately similar rates of elect and file and hold outcomes, and less than 10% of direct return to DOE decisions. Of course, hold decisions will also be reevaluated case by case over time, but in my experience, I would estimate on average about half of these also eventually result in elect and file decisions. Next slide, please. Now, with this background on the invention decision-making process, it's time for my 5 tips on how Argonne selects inventions. Tip number 1 relates to prior art considerations to determine if the invention is indeed new and novel. A common challenge here is that even conceptual comments in scientific papers or the patent literature may already suggest the invention, even though it has not previously been reduced to practice. In short, if you're the first to actually achieve a certain result, there may not be a path to IP protection if it is already known to be a good idea or a possible solution. A recent example I encountered of this issue relates to battery electrolytes, where the scientific prior art was limited to those compounds actually demonstrated to improve performance, whereas the same research group had filed patent applications claiming a very broad range of related but not yet demonstrated compounds as well. My second tip relates to surprising and non-incremental improvements over existing technologies. For example, it can make for a compelling case when a technology combines 2 already known ideas, materials, or approaches, but produces an outcome that is unexpected or much more than the sum of its parts. Tip number 3 involves an assessment of commercialization prospects, often in the context of return on investment for patenting costs, such as the likelihood of licensing outcomes or potential fit for being leveraged for sponsored research projects or funding opportunities. Some common DOE funding opportunities where laboratory IP is important include the Technology Commercialization Fund and the Small Business Innovation Research Program, or SBIR for short. Tip number 4 involves considerations relative to Argonne's IP portfolio and priorities. For example, does the invention complement or further enable an existing Argonne technology? Or does the invention address a technology gap in our portfolio or align with a growing strategic priority area? Some examples may include artificial intelligence, as discussed earlier by Austin, quantum science, solid-state batteries, or technologies to enable a circular economy. My final tip is more technical in nature, and usually relates to process or method technologies. For these inventions, it's important to consider how identifiable the resulting materials from a new or improved process will be. As the more easily or directly the production process can be identified, the more compelling the technology becomes in terms of commercialization potential to prospective industry partners. This is because being able to identify the process used to make a product provides a means to investigate process-related IP infringement. Examples of identifiable features could relate to levels or types of impurities, or the presence of distinct structural or compositional features. This now concludes my part of today's presentation, and while unfortunately there's no magic formula for weighting these selection considerations, these are all topics that frequently come up during Ipdg meeting discussions and which I hope will be helpful for your next invention. Thank you, and please feel free to reach out to me if you have any follow-up questions or would like to discuss any of these invention selection tips in more detail.
Thank you, Greg, for sharing those tips to researchers to help make their inventions even more likely to be filed as a patent application. Next up is Mark Hilliard, who has served as Argonne's Chief Patent Counsel for over 20 years. In that time, he has overseen the patent protection of inventions from every part of the lab. Today, via recorded remarks, Mark will share his top 5 things a researcher needs to know about patents. I turn it over to Mr. Hilliard.
Good morning. My name is Mark Hilliard, and as Argonne National Laboratory's Chief Patent Counsel for the last 20 years, I have had the responsibility and pleasure of reporting the laboratory's inventions to DOE and managing the prosecution and maintenance of the laboratory's patents. Today I will highlight 5 things a laboratory researcher needs to know about patents. 1. Patents are valuable to DOE, the laboratory, and you. 2. Without your attention and diligence, patent rights will be lost. 3. The laboratory invention reporting and review process is simple and only requires a few hours of your time. 4. The laboratory will provide patent counsel to draft and file a patent application claiming your new invention with your assistance and approval. 5. Successful inventors are repeat prosecutors. Patents are valuable to DOE, the laboratory, and you. A patent is a legal right granted by the United States government to anyone who invents or discovers any new and useful process, machine, article of manufacture, or composition of matter. A patent provides the right to exclude others from making, using, offering for sale, or selling the invention in the United States for 20 years. The exclusive rights provided by a patent enables a business to be the exclusive source of a patented product or service, thus allowing the business to increase its profit and helping justify the significant investment needed to bring new, cutting-edge technologies to market. For the laboratory, a patent is a valuable tool for transferring technology invented by Argonne's inventors to business for commercial use. DOE has designated technology transfer as a mission of the laboratory because technology transfer is essential to capturing the commercial value of your new discoveries and inventions and building new businesses and creating new jobs. The laboratory and its employees have agreed to report all Argonne's inventions to DOE, and DOE reviews all inventions not patented by the laboratory for possible patenting by DOE. Argonne patent rights can be licensed to facilitate commercialization of laboratory technology and to return licensing royalties to the laboratory and the laboratory's inventors. As incentives to encourage invention reporting and patenting, the laboratory shares 34% of royalties with inventors and provides cash awards of $250 upon filing of a patent application and $500 upon issuance of a patent. Your creation and protection of laboratory patent rights also support laboratory relationships with commercial businesses interested in working with you to invent and develop new Argonne-invented technology. Your patent applications and patents not only can be licensed, but also evidence your knowledge and ability to create and protect intellectual property, which enhances your professional reputation and the laboratory's reputation with businesses interested in working with Argonne to develop and commercialize new technology. Without your attention and diligence, patent rights will be lost. Public disclosure before filing a patent application in the United States Patent Office destroys and can compromise patent rights. Public disclosure is not limited to a printed publication and can be merely a disclosure without an obligation of confidence to one person. A U.S. patent can be obtained even after public disclosure by an inventor if a patent application is filed within 1 year of the first public disclosure by the inventor. So in the best case, report your invention before public disclosure, and if no longer possible, as soon as possible after your first public disclosure. It is possible to disclose your invention in confidence without affecting your patent rights, and Science and Technology Partnerships and Outreach, SNTPO, and legal can work with you to obtain a non-disclosure agreement to allow a confidential disclosure of your invention to a third party. As you seize your day, seize the laboratory's intellectual property by recognizing new and possibly valuable discoveries of your own and your colleagues, and considering whether you should immediately report these inventions for review, and if not, remembering to report the inventions before you publicly disclose the inventions. Don't just pay attention to your own discoveries, but include interesting and significant discoveries of other laboratory inventors and encourage reporting of their inventions before publication. It is especially important for managers and mentors to not only report their own inventions, but to educate and encourage new employees to report and protect all of Argonne's intellectual property. Conceptual inventions are patentable, and you do not need to wait for completion of your research to report an invention for review. Only the first inventor to file a patent application for an invention in the Patent Office receives a patent for that invention. Thus, best practice is to report, review, and file your patent application as soon as possible. A good time to double-check whether you should submit an invention report is when you begin to draft a new manuscript for publication. The initial draft of your manuscript can be used to create an invention report, and your invention can be reviewed before the manuscript is approved for publication, preserving all patent rights. Keeping the importance of capturing the laboratory's intellectual property in mind as you work and make new discoveries, and then diligently reporting new inventions before publication will fulfill your obligation to DOE to provide the intellectual property necessary to help transfer the results of your genius and hard work to industry for commercialization. Finally, it's very important that if you are informed by a colleague at another laboratory, university, or company that you have been named as a joint inventor in a third-party invention report or patent application, that you immediately report the third-party invention to the laboratory. Do not sign any third-party legal agreements or patent application documents, but immediately ask legal to review and approve any third-party documents you are requested to sign. Failing to report third-party joint inventions promptly can result in a loss of DOE's and the laboratory's patent rights. The laboratory invention reporting and review process is simple and only requires a few hours of your time. To report an invention to the laboratory, you need only to fill out ANL Zinc Form Invention Reporting ANL 1082. Information needed to fill out the form includes a description of your invention, a listing of all inventors that you believe may have contributed something patentable to the invention, and all sources of funding that supported the work that resulted in the invention, including the relevant DOE B&R funding codes. Typically, inventors focus attention on the novelty and importance of their invention in a few pages or even a few paragraphs, if adequate to describe the invention, and provide draft manuscripts or presentations that contain additional details of the invention. Receipt of the ANL 1082 form is acknowledged with an ANL invention number, and in due course you will be provided with a draft formal invention report for review and modification if desired, and for your signature. The signed invention report will be reported to DOE and S&TPO, fulfilling the laboratory's and your duty to report the laboratory's inventions to DOE. After receipt of the invention report, S&TPO will schedule a 1-hour intellectual property decision group meeting to review the invention. The inventors, their managers, the S&TPO business development executive responsible for the invention, and patent counsel will attend the Ipdg meeting. The inventors typically provide a short presentation focusing on the novelty and advantages of their invention, and the attendees discuss the best course of action. The Ipdg meeting is the inventor's opportunity to educate the business development executive and the inventor's management of the importance of the invention and how the new discovery advances science and provides advantages that would be useful to industry. Subsequently, the business development executive will issue minutes summarizing the relevant facts determined at the meeting and providing the next actions for the invention. Typical actions include holding the invention for the results of additional work or information, returning the invention to DOE to allow DOE to review the invention for possible patenting by DOE, or preparing and filing a patent application. The laboratory will provide patent counsel to draft and file a patent application claiming your new invention with your assistance and approval. To obtain patent rights in a new invention, a formal patent application must be filed and prosecuted in the U.S. Patent Office. Patent prosecution is the process of responding to Patent Office requirements or objections until the Patent Office examiner allows the patent application and the Patent Office issues a patent. The laboratory will engage outside patent counsel with expertise in the technical field of the invention to work with the inventors to draft a patent application to fully describe their invention and claim the novel aspects of their invention. You will be unable to add new description to your application after filing. Thus, it is important to describe your invention as accurately and with as much detail as possible, including all possible variations of your invention, even if only conceptual. After the inventor's approval, an application will be filed in the U.S. Patent Office. This will typically take a few months, but it can be filed more quickly if necessary. After filing in the Patent Office, the inventors are free to publicly disclose the invention without affecting their patent rights. In 18 months from your filing date, your application will be published and available on the USPTO's public website. In approximately 20 months from your filing date, a Patent Office examiner will issue an office action comparing the invention claimed in your application to prior art found by the examiner. In almost every case, all to a majority of the claims of your application will be rejected by the Patent Office examiner as lacking novelty and being obvious in view of the prior art. Often the examiner does not have your technical expertise and understanding of the invention and prior art, and you can help your patent attorney explain the technical and scientific differences between your invention and the prior art to the examiner. Your patent attorney will work with you to prepare a response to the office action to explain how your invention is different from the prior art, and if necessary, amend your patent claims to distinguish your invention from the prior art. Typically, this prosecution process of rejection and response is repeated a number of times until the examiner approves your application and the Patent Office issues an allowance of your patent, with a patent typically issuing 2 to 3 years after filing. Successful inventors are repeat prosecutors. Successful inventors over their careers typically report for patenting all of their significant inventions, building a portfolio of patents and increasing the likelihood that their intellectual property will result in commercial interest, licenses, and new relationships. Working with the laboratory's inventors, S&TPO, and legal to protect the laboratory's intellectual property is a rewarding experience, and we look forward to meeting with you to discuss your next invention.
Mark. Final presenter today is LaShondra Moore, Argonne's intellectual property paralegal. LaShondra is responsible for various partnership agreements, including sponsored research agreements and non-disclosure agreements, as you've heard about today. Via recorded remarks, LaShondra will conclude today's session of the Intellectual Property Management Seminar Series by reminding everyone of the importance of non-disclosure agreements, as well as providing actionable tips. No further ado, I turn it over to LaShondra.
Greetings and welcome to Don't Forget the NDA. My name is LaShondra Moore, IP Paralegal in Argonne's Legal Department, and I would like to talk briefly about why it is important to have an NDA in place before engaging in certain discussions. You ask, what is an NDA? Well, an NDA is an acronym for non-disclosure agreement. NDAs are also sometimes referred to as confidentiality agreements. NDAs are legally binding contracts between the parties that establish obligations to handle certain information as confidential. NDAs create legal obligations for the recipient to protect and not further disclose information. In other words, NDAs exist to ensure a company's sensitive data remains safe and secure. As you have heard in other presentations, public disclosures of inventions bar the inventor from seeking patent rights abroad and start a 1-year time period for the inventor to seek patent protection in the United States. NDAs allow parties to exchange inventive information with other parties without triggering those bars. In other words, NDAs allow for non-public disclosures of inventions and protect patent rights before an application is filed. Next slide, please. How do NDAs help you? Well, NDAs allow parties to share non-public information and collaborate more closely on matters important to the parties. In the research context, NDAs can help facilitate candid discussions on the capabilities, needs, and problems of a company. Those candid discussions may reveal how Argon can help that company solve a problem. Many times, NDAs lead to collaborative or sponsored research agreements. As mentioned on the last slide, NDAs also play an important role in protecting inventions prior to patent filings. NDAs are critical for allowing discussions with potential commercialization partners early in the invention protection process. The NDA also defines how information can and cannot be used, sometimes referred to as the purpose. The purpose should be defined as accurately as possible to ensure the minimum necessary use of the information. In other words, the purpose should cover the permitted use of the information, and when requesting an NDA, please be as specific as possible when identifying the purpose of the disclosure. Next slide, please. Need to know for NDAs. Argonne does have certain limitations in what federally funded information it can protect. Under our prime contract, all generated information is deemed delivered to the U.S. government with unlimited rights, unless some exception exists. One important exception is for inventions and software for which the laboratory has not yet perfected its IP rights. If you are requesting to share Argonne-generated information under an NDA, please include that, or we will ask, has it been reported as an invention or software? An NDA will not always be necessary or appropriate. Consider whether an NDA could impose obligations that could actually impede your programmatic goals. Consider whether an NDA will prohibit you from including critical technical information in a proposal to DOE or a publication of your results. Please also be aware that any scope of work for a sponsored research agreement must be non-proprietary and should not include any NDA information. Also, please keep in mind that NDAs create ongoing obligations to protect and track information received under the NDA, typically for 5 years or more. Before requesting an NDA, carefully think through who at Argonne would need access to this information, where the information will be stored, and who else may have access to this information. Of the administrative requirements, one of the most important is that under Argonne's standard NDA, the disclosing party must mark the data as confidential. If you will be the discloser of Argonne inventions, please mark emails, documents, and communications as confidential. In the case of oral discussions, please follow up with an email summarizing what was the confidential information that was discussed. When receiving information, it is also important to note whether the collaborator's material has been marked as confidential or proprietary. Argonne employees and contractors should handle all information consistent with its restrictive markings. Next slide, please. How do you request an NDA? Well, the first step is to request in Zinc. I am the person responsible for the NDA, and I will create the NDA and send it out and negotiate the terms. Please take a mental snapshot of this slide and feel free to contact me with any questions. Please do not hesitate. I will be more than happy to answer any questions that you have. Thank you.
Thank you, LaShondra, for helping to provide our researchers with tips and tricks to protect their inventions through non-disclosure agreements. Thank you all for joining us today for our second of 4 IP Thursdays throughout April. I would like to thank our speakers for sharing their varied and valuable perspectives. We look forward to seeing you at the next of our IP Thursday series. The next meeting will be on April the 22nd at 11 a.m. and is entitled Copyrights, Creating Communities, Driving Research Collaborations, and Creating Impact Through Licenses. For more info or to register, please search IP Thursdays on My Argonne. Thank you again and have a great day.